While I was in D.C. for the Apollo 50th anniversary celebrations, I spent the day at Smithsonian Exhibits. Smithsonian Exhibits plans, designs, and builds exhibits for many of the Smithsonian museums and offices that create public-facing exhibitions. And of course, they don't just design and build the exhibits, they install them as well. Chris Emo, head of production, talked to me about how his team is actually working on installation before they even start a build.
All right, Chris. So, the exhibit gets conceived, it gets written, it gets designed, it gets executed and built, and then it's time to put it in the museum and install it. And that's the easy part, right?
We hope, but not always.
It's obviously I'm leading. I would imagine there's a whole new set of problems to solve once the exhibit's done and needing to be installed.
Well, we actually start working on the install even before we build a thing.
Really?
We will, access. What's the smallest door it's got to fit through? Not every museum's got a giant freight door, giant freight elevator. So we go to the site early, we do site survey, we understand the load-in route, what it's going to mean to even get it off the truck. Sometimes we're unloading in the street and carrying it in. So we start early on,
potentially, right.
Before any of the shop drawings or technical drawings are done, we have to gather all that information. Then we will build the thing, but we end up setting it up in this space. We'll do trial setups, tech setups, where we will put all the components that we build together. We'll do finishing steps. We'll pre-install as much as we can. We try to arrive at the site with basically a kit of finished parts.
Right.
That we're just assembling together. We're doing very little construction on site. Now that's the goal. We don't always get there, but that's the goal.
So this, I'm looking at this particle board oval here on the floor. Is this exactly that? Is it you speccing something out for how big it's going to be?
This is a template that we have created. We're about to build 4 oval pods for a project. This is a template that we've done at full scale so that we can start to understand the size of the pod and start to understand relationships between where the walls will be. And we have these cantilevered headers that are out on the 2 long ends of it. So we're trying to get the spatial relationships down before we go any farther with the model.
And I would imagine that seeing things full size like that would affect every other department's decisions, graphics, etc.
It's feedback for those departments. This one's got a heavy graphic component to it. So if you've ever done anything with radius or with circles, radius changes have a big impact on width along that arc.
Yes.
So now we've got an oval, which kind of complicates it a little bit, but determining graphic sizes, you have to do the physical build in order to really nail that stuff down if you want really tight fits. You can't really do it on paper. Even with the computers, it gets a little hard to know exactly. So we have to develop this stuff in stages, and there's feedback loops to graphics, to final art, and all of that, and it works hand in hand all the way along.
Are there occasionally early stages where you'll just run over, grab a few sheets of gatorboard or cardboard and run them on the table saw and slap them together with tape just to see how it looks?
No, we will do full-scale mock-ups of parts. We'll do 2 or 3 if we need to as we develop it.
How, at this stage in your career, are you still sometimes surprised when you mock something up in full size and see it?
Constantly.
Me too.
Constantly. It
doesn't matter how long I've looked at the drawing and looked at size references. When it's in front of me, it's different than
always different than you thought, and you always learn something you didn't know before.
Obviously, the goal is to get on site with a kit for install that's really straightforward. But how often do you get on site and discover, oh wow, this wall has a slight bend in it, or little? Obviously something like that would be rare, but
it does happen though, and true plumb square flat planes, perpendicular planes, you can never assume that you're going to have any of that. We have to build all of the compensation for this stuff into the structure we're building. If you've got a long structure and the floor is going to drift out, it's got to be level, or it's at least got to be in a plane that follows the floor. So you have to anticipate all this stuff ahead of time. You have to install leveling feet, or you have to have a method of doing all this.
There's a thing that happens in San Francisco specifically,
yes,
which is that you can never build shelves in San Francisco that are level, because if you make them level, they won't look level because none of the buildings are
none of the buildings
level.
are
I did one where I built it, and my girlfriend at the time I built shelves for her in her shop in her basement, and she was like, they're not level. And I'm like, sweetie, they're totally level. And she's like, no. And I showed her, but the problem was the basement was like this, so I had to make them off square to make them look right. That probably happened.
It does. Mostly we have problems with the floors not being flat.
Right.
And over the length of the exhibit, things tend to drift drift down, they drift up. So you just basically have to do that. A lot of times we'll construct with bases. The kick will be this layer all its own. We lay the kick down, we get all the kicks put together, get them all level, then we set all the cabinetry or all the walls or all the rest of the structure on top of that. So
the kick is the border between the
kick is
wall and the
that
floor.
4-inch
Right.
layer that hits the floor, that's got the kick face on it.
So if that's level on its
easy
top,
to get that all
yes,
leveled and in place.
got it.
Then we just drop all components in on top of that, and it goes very fast if you do it that way. It's much harder if you're bringing whole big units in and trying to get it all flushed up and tight joints and all of that.
Well, I also imagine you're working with many different kinds of walls, some of them historic, and thus you can't necessarily
Yeah, there's
drill
lots of
into
places
every
where we
wall.
can't actually touch the wall or connect to the wall at all. Wow. So everything's got to be self-supporting. Anything that's questionable, of course, gets engineered out to make sure it's not going to fall over.
Right.
You know, all of that. But yeah, there's lots of considerations.
You have considerations of that. You have ADA considerations for movement through the space as well.
Mostly that is addressed in the design end of things. You know,
sure.
Obviously we're building what's designed, but ADA is a big thing. We do a lot of work in that area. We've got some projects that we are doing that are basically our research or kind of prototype projects for working on ADA.
Yeah.
Visually impaired stuff.
Nice.
You know, we do a lot of different things in that area.
I love the idea that you build these foam core mock-ups. There's a picture that we found when we were doing research for a project of the original Mercury capsules. Before they started building the real one, they mocked up a dozen different sizes and designs of a capsule in plywood. And there's a picture of a warehouse in California.
With all of these.
Yeah. And it looks so rudimentary because it is, but of course, even at the highest level of engineering, you still have to see it in order to understand how to engage with it, don't you?
When the idea becomes real in a material, you're going to learn something.
Amazing. I really appreciate it. Thank you so much.
Thank you.
This is such a fun journey seeing what you guys do, and it looks like you're all still having a lot of fun.
Yeah, I wouldn't do it if I wasn't.